I am Anil Kumar. Let me thank all the viewers and subscribers for watching my video. Here is an excellent example based on Pythagorean trigonometric identity. We'll find the equations from the given conditions. You can always join my classes by sending an email on the address given. Enjoy the journey of success. Pause the video and answer these questions, and then look into my suggestions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll learn about how do we prove trigonometric relations when some condition is given to us. Here are 4 questions. You can pause the video, answer these questions, and then look into my suggestions. In case you want to learn from me, you can send an email on the address given. You can also fill the form which is being shared in the description. The question here is, if cosecant theta plus cotangent theta equals to x, find the value of cosecant theta minus cotangent theta. Question number 2. If cos x plus sin x is square root 2 cos x, show that cos x minus sin x equals to square root 2 sin x. Question 3. Secant theta equals to x plus 1 over 4x. Prove that secant theta plus tangent theta is 2x or 1 over 2x. Question number 4. If a cos x minus b sin x equals to c, prove that a sin x plus b cos x equals to plus minus square root a square plus b square minus c square. So, try these questions and then look into my suggestions. So, what is the strategy which we are going to follow? Let's look into this strategy first. All the above questions can be solved by Pythagorean identities. I hope you remember them. Let me just write down these identities. So we have cos square theta plus sin square theta equals to 1. 1 plus tan square theta equals to secant square theta, and 1 plus cotangent square theta equals to cosecant square theta. Now, as you can see, these Pythagorean identities can be written in different forms. Cos square theta plus sin square theta, you could actually write cos square theta as equal to 1 minus sin square theta. Does it make sense to you, right? Similarly here, you could write 1 as secant square theta minus tan square theta. And in this case, we can write 1 as cosecant square theta minus cotangent square theta. Correct? Not only that, once you have difference of square, you can write this as sum and product, right? So remember that we also have a very important formula, which is a square minus b square is what? Is a plus b times a minus b. So that can help you further factor and give you an equivalent expression which can help you solve the above questions. Is that clear to you? So I say that this is the hint to solve the above questions. Now with this hint, you should be in a position to answer them all, right? Some of them can be tricky though. Okay, in any case, you can always contact me on the email address given here. Now let's look into their solutions one by one. Very first one is cosecant theta plus cotangent theta is x, right? So we are given cosecant theta plus cotangent theta as equal to x. Find the value of their difference. So, what does that remind you of? Well, clearly, we could say that we have this identity, which is 1 plus cot square theta is cosecant square theta. We're talking about difference and sum. That means difference of squares, right? So I can write this as cosecant square theta minus cotangent square theta is what? Well, that is equal to 1. The left hand side can now be factored. So we have cosecant theta plus cot theta times cosecant theta minus cotangent theta equals to 1. We need to find what is the value of difference, okay? So we need to find this value. We can isolate this. Cosecant theta minus cotangent theta is equal to 1 over divided by their sum, which is cosecant theta plus cotangent theta. And that is given to us as x. So our answer will be 1 over x. Do you see how systematically we have rearranged the Pythagorean identity and got our solution? So basically the strategy, you understand, is rearrange the trig Pythagorean identity, right? Exactly like this. You have to follow some changes and you'll get the result. Let's look into question 2. In question 2, we are given cos x plus sin x is square root 2 cos x. We need to find cos x minus sin x. Right, so equals to something, right? Okay, how do we figure this out? Let me use strategy 2 here, right? So I'm using a new strategy. That is, we'll square both sides. And then simplify. However, we'll still use the Pythagorean identities. Okay, so let's begin by writing down what is given to us, which is cos x plus sin x equals to square root 2 cos x. So if I square both sides, what do I get? Well, let me write this square thing first. Whole square is equal to square root 2 cos x whole square. Now here we get cos square x plus 2 cos x sin x plus sin square x, which is 2 times cos square x. Now from here, how do we get cos x minus sin x? That is what we have to think about. Okay, so we can take these terms to the right hand side. So we get 2 cos square x minus cos square x. We have here plus cos sin square x. And we are left with 2 sin x cos x. Okay. Now, 2 cos square x minus cos square x is cos square x, right? Is cos square x. So we actually brought it on the left side, so this becomes minus, right? We change the side, correct. So that is cos square x minus sin square x, and this is equal to 2 sin x cos x. Well, difference of squares, we could write this as cos x plus sin x times cos x minus sin x equals to 2 sin x cos x. Right? So that's what we get. Let's move on to a new page to complete this. So what we have here is cos x plus sin x times cos x minus sin x equals to, what was it? 2 sin x cos x. 2 sin x cos x, correct? We just copied what we had derived at. You can match, right? So cos x plus sin x times cos x minus sin x is 2 sin x cos x. Next page. Now here we need to now find what is cos x minus sin x, right? So let's isolate this. So we get cos x minus sin x equals to 2 sin x cos x divided by cos x plus sin x. Now, this cos x plus sin x is given to us as square root 2 cos x. So we can write this as 2 sin x cos x over square root 2 cos x. Now that can help us simplify. And then what do we get? We get 2 sin x divided by square root 2, which is square root 2 sin x. Do you see that? We get the result. And that is what cos x minus sin x is equal to. And that is what we wanted to, right? So this is how we can actually derive this particular expression. So I hope all the steps are absolutely clear. Let's look into what we really did. So basically, we started with what is given to us. We squared both sides, rearranged the terms, got cos square x minus sin square x, wrote it as that product of sum and difference, and then isolated what we really wanted. Substituting what is given, we got a result. Perfect. Great. Now let's look into question number 3, which is secant theta equals to x plus 1 over 4x. We need to prove that secant theta plus tangent theta is 2x or 1 over 2x. So now, we are given secant theta. We can find what tan theta is and then add and get the result, right? So here, we can find what tan theta is, right? How will you do that? Well, we know 1 plus tan square theta is secant square theta. And therefore, tan square theta is secant square theta minus 1, or we have tan theta equals to plus minus square root of secant square theta minus 1. So we can substitute what is given to us about secant and then work out, right? Once we get tan theta, then we'll just add them and get the result. So we can say this is plus minus square root of what? Secant is x plus 1 over 4x whole square minus 1 within square root. So that is the value of secant theta. Let's find this out. So tan theta is what? Let's evaluate or rather simplify. So we have x square plus 2 times ab, that means x and x cancel. So half, right? Plus 1 over 16 x square minus 1 within square root, right? So that is the value of tan theta which you get. Now, clearly, you can take 16x square as a common base in this particular case, right? So when you get that as a common base, you can simplify it further. Or you will also see here that half minus 1 is minus half, right? So we can also do it like this. X square plus 1 over 16x square, right? And here we have half minus 1, which is minus half, right? Does it make sense? Well, let's rearrange. It is x square minus half plus 1 over 16x square. Now that is a perfect square, right? Twice AB, 4x, you get the idea? So this could be written as x, well, plus minus for all these terms, right? So that could be written as x minus 1 over 4x whole square, right? So that is what we have in the result, right? This whole square, right? So tan theta is all this. Square root of this, that means plus and minus x plus 1 over 4x. So that becomes the value of tan theta. We know sin theta, x plus 1 over 4x. This is x minus 1 over 4x. So let's write down what did we get. So now let us write down what did we get. We are given secant theta equals to x plus 1 over 4x. We found tan theta to be equal to x minus 1 over 4x with plus and minus, right? Let me rewrite this, plus and minus. And now, when you calculate what is, let me write here, secant theta plus tan theta, then it is equal to x plus 1 over 4x plus and minus x minus 1 over 4x. And that could give you two values, either 2x or 1 over 2x. Does make sense? So that is how we could prove that secant theta plus tan theta is 2x or 1 over 2x. Perfect. So I hope that makes sense. Let's look into question number 4 now. Now, question number 4. I'd like you to pause the video, answer this, and then look into my suggestions. We could adopt many different strategies here. We are given a cos x minus b sin x, right? That is what we are given. We need to figure out what is a sin x plus b cos x. And we are also given kind of a result here. A square plus b square minus c square. And if I open this up, this becomes a perfect square. You get the idea. So looking into this scenario, the approach which I would like to adopt at this particular stage is what? So can you tell me what approach will really work best in this particular case? Think about it. We could square each terms, right? And then figure it out. So if I square all this, then we need in terms of sine and cosine. So we are given this is equal to c. Now if I square this, I get a cos x minus b sin x whole square equals to c square. You get an idea, right? So if I expand, I get a square cos square x minus 2ab cos x sin x plus b square sin square x equals to c square. Since we now need a sin x, it's better to write cos square x as 1 minus sin square x. So we get this as 1 minus sin square x. And this term is okay. 2ab, both are there. Cos x sin x. Here, we can write sin square x as 1 minus cos square x equals to c square. Now you can open the bracket. A square minus a square sin square x minus 2ab cos x sin x plus b square minus b square cos square x equals to c square. You get the idea. Now we can bring c square on this side. So we get a square plus b square minus c square equals to all other terms on the right hand side. So on the right hand side, we'll get a square sin square x, and then we have plus 2ab cos x sin x, and we have plus b square cos square x. Now that is a sin x plus b cos x whole square. You get the idea. So now, from here, let's go to the next page and write down. So what we have here is a square plus b square minus c square equals to a sin x plus b cos x whole square, right? We can square root it. with plus and minus and get the result. Do you see that? So that is how we are going to solve the fourth question. Let us go back and review our strategy for this question. We were given a cos x minus b sin x equals to c. We just squared both sides, expanded, and then wrote cos in terms of sine and sine in terms of cos. Expanded, simplified, and got our result. Do you see that? That's the beauty. So I hope you understand and appreciate the solution of these questions. All four of them solved. Similar strategies. Basically, we were looking at the Pythagorean trigonometric identity and then solving them. I hope you understand how we relate these Pythagorean identities and solve very difficult examples. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.